Wow.
Okay,
Wow.
all right,
Inside joke. Inside joke.
okay.
Shaded pole motors, very low starting torque, not as efficient as PSC motor. A portion of the run winding is shaded to provide the balance and magnetic field that allows the motor to start. Heavy copper wire or bands are used to shade the run winding, manufactured in the fractional horsepower range.
Shaded pole motors. The most inexpensive motor out there. A lot of fractional horsepower motors. The wiring diagram is just one winding, right?
Okay.
Okay, it has a copper band around one part of the iron,
That's
which disturbs the magnetic field and
okay.
allows the rotor to start in a certain direction. So with this, with the motor laying in the iron core, this magnetizes first, and then this one magnetizes later. So it pulls that motor around in one direction.
And is it one pole or is it? Because all the wires look connected.
That looks like 4 pole.
A full four? Oh, so it's like that and then it's a four.
Yeah.
So it was like two individual, then it'll be two. But if it's all like that, it's four.
Yeah.
Mm.
Something like that. Yeah.
Could be.
Three-phase motors, normally used on commercial applications, must have a three-phase power supply, has no start winding or capacitors,
Capacitors.
very high starting torque, rotation of motor can be changed by switching any two power lanes.
Okay, so three-phase, if you do any commercial work, you're gonna be running into these three-phase motors. A lot. Let's see, they have this is what they are, and this is what they look like. 3 run windings. You got T1, T2, and T3. So, this is what the power supply looks like. There's 3 separate voltages,
Okay. I see.
all out of phase. Okay?
Very out of phase.
120 degrees out of phase,
120 degrees.
right? What we got here? We got one there. And we got one there, 90 degrees.
So they meet at certain points.
Right there, 120 degrees, yeah. So it's 3 separate voltages. So when one energizes, it spins, the other one energizes, and it keeps going. So these are actually, the phases are running at 60 cycles per second. So you actually have 3 of them, so you're constantly having something happen in this current 120 times.
So it's like a series
Or-
of just of a circle.
180 times, no, 240 times,
240.
something like that. What's 3 times 60?
3 times 60. 3.
180.
180. 180.
So 180 pulses per second, okay? Okay, so these have the most starting torque ever, because this is what happens, this is what you get from the generator,
Okay.
from the dam.
So then.
Yeah.
Oh.
So
Thought
our power is generated in 3 phase. So when you get a 3-phase current like this, and a motor like this, as soon as you hit the power, as soon as you turn that motor on, it locks in to that, and it spins, and it starts.
Wow.
So it starts immediate.
So instantly, like once you
Instant.
turn on that switch, you.
Yeah, it's bam, bam.
Damn. So would like a gas power generator be the
No.
similar thing, or
No, I think they just generate single phase.
single phase? So it has to be something big, obviously a dam, or like
Yeah, there's something, we have three phase here.
our dams.
Yeah, we have three phase. I told you we had three phase. I even have three phase access right back here.
Oh, yeah.
Right there, remember?
Slipped my mind.
Mhm.
Slipped my mind.
Single phase hermetic motors, hermetically sealed from the outside air, similar to single phase motors, use relays to remove star winding. They do not use switches. Use run capacitors for increased efficiency. Designed to operate in a refrigerant atmosphere. Motor terminals identified as common star.
Okay, so the hermetically sealed motors, that means that the compressor and the motor is all hermetically sealed into a container, like the compressor down there on the floor, in the back, right? Right, right? Wanna see that? Okay. Wait, where are you going?
Let's check it out.
Okay. We'll be able to touch it later on.
What? Able to touch deep stuff?
Okay, so if it's contained and there's a compressor and a motor inside that container, which is exposed to the refrigerant in the system, that's why they're not gonna use a centrifugal switch. Or centrifugal,
Yeah.
yeah.
I don't know the word, so I'm not gonna attempt.
Centrifugal.
Yeah.
I know
Yeah,
it looks like centrifugal, but it's centrifugal.
I'm not the guy for any grammar.
That's how you spell centrifugal?
Yeah.
I thought centrifugal was actually a word. Cause isn't there centrifugal force?
Centrifugal.
That's pronounced centrifugal force?
Centrifugal.
I don't know about that,
Wow.
but that sounds right, I guess.
Well, you learn something new every day. Good.
I'm searching it.
The potential relay. Used on motors requiring high starting torque. Coil with very high resistance, normally closed contacts. Relay operates on the induced voltage across the start winding. The contacts open when the induced voltage increases. When the induced voltage drops, the relay contacts close.
Okay, this is a pretty interesting little device. It looked like that.
Oh, it looks like a beacon.
Yeah, it looks like a relay, but it's not a regular relay. It's what they call potential relay.
Oh, potentially.
Potential, the same word for potential would be what?
Another word for potential.
Yeah, another word for potential.
Possible?
Possible. Potential.
Try volts.
What? Oh,
I would have never thought that.
So it's a voltage relay, and it works off of the voltage off of that starting winding. So when this thing goes up, runs, and it's up to speed, there is a voltage generated across that start winding, we know, because of transformers. So you've got this start winding right next to this run winding. And we know from transformers that if you have a voltage going through one winding and you have another winding that's twice or three times longer than the other winding, then you basically have a step-up transformer. Because the windings are right next to each other, so it's inducing a voltage into the start winding. It's utilizing that voltage to power this relay. So that means that this compressor has to be married to this relay. They're not interchangeable, okay? Understand that?
Kind of.
Kind of. If you look at the voltmeter, you got about 175 volts across the start winding. If you look at the voltage coming in, it's 115 volts. If you guys remember when we checked that thing over there,
Oh.
when we checked the voltage, we had like 400 volts coming off of that across the start winding. It's exciting. So we're making more voltage. So this is actually seeing that voltage. So that 175 volts, that coil right there knows what to do when it reaches that 175 volts. It knows to de-energize, open and close contacts. Okay? That's a pretty amazing little deal.
Yeah.
Somebody thought that up. I don't know who it was. Pretty slick. Whoa.
But he came rich.
Okay. So that's kind of how the potential relay works. This is what it looks like. Those potential relays are all the same. They all have identifying terminals. 1 or 2, 5, and 1. Those are all identified. So all of them are gonna have this. They have a dummy terminal here and a dummy terminal here. That means that just, you can put terminals, you can put spade terminals on there and use those as a connection point.
Oh.
So underneath there's nothing hooked to them, it's just for making the connections without
Okay,
having
that
to
makes sense.
cut wires and splice wires.
Why is
Huh?
there dummy terminal? I was wondering why there is a dummy terminal.
They're not that smart. Okay, so in between 1 and 2, there's a set of contacts. That's the contacts it's gonna open, right?
Oh, yeah.
And between 2 and 5, that's the coil.
Okay.
Okay, they're all the same. All of them are the same. This is what we did when I was in school. Check this out. We had to wire this. A compressor motor with a run capacitor and a start capacitor and a potential relay. That was part of our final. We had to do that without a schematic.
What?
And I think you have to do that here too, in the advanced, but.
But that's once we reach that.
Yeah, and actually knowing how to do that, I was actually asked that on an interview once. Give me a whiteboard and do the components up there, and he said, okay, now wire it hard start with potential relay. So I did. Because I was forced to remember how to do it. And my instructor says, you're gonna know how to do that, you're gonna remember. You're not just only gonna remember, it's gonna be second nature to you. You're gonna, just like tying your shoe. You're gonna know how to do it.
I'm just gonna come to instinct.
Yeah, so it's pretty, you gotta focus on that. Cause somebody out there might ask you to do that for an interview. If you can't do it, bummer. Here's another picture. You can see the terminal connections, 5, 2, and 1 down there. Barely see it on that one, huh? That's not a good one, huh? Okay, so.
The current relay, used on fractional horsepower motors, used with fixed or, I don't know that word.
Fixed?
Or fixed, no.
Orifice.
Orifice?
Yes, fixed orifice.
Metering device, low resistance coil in series with the run winding, normally open contacts in series with start winding. Upon startup, only the run winding is energized.
Okay, so this is another type of relay. It's called a current relay. Okay, so this is, the last one was called what?
Oh, the potential.
Potential. Okay, could be called a voltage relay, really, because potential means voltage, right?
Okay, voltage.
This is current.
Okay.
What's different? We know the difference between voltage and current, right?
Yes.
No?
Which one's current?
Current is.
Current?
It's like the flow.
Current is
And
flow, voltage is pressure.
Yeah, pressure.
Okay. So this is how it works, right there. I can't read that. I'm not allowed.
I mean, I could tell because of the glasses. The current relay. The motor draws locks rotor amperage. The increased amperage close the relay contact. The start winding is energized and the motor starts. The amperage drops and the relay contacts open.
Check it out. This relay coil comes from L2. It looks like it's always in that circuit. It never goes out of that circuit. It's always in there. It's always energized, even whenever that compressor's running. So the lock rotor, we talked about the LRA, lock rotor amperage, it's about 5 to 7 times greater than the running load. Well, it sees that lock rotor current, and as soon as you start it up, this thing pulls that plunger up and it connects these two contacts, putting the start winding and or the start capacitor in the circuit right there. And as soon as it starts running, the amperage goes down and that doesn't have enough current to hold that plunger up, so it falls. This relay and the potential relay are positional. That means what? What?
It matters where you put it. Well, doesn't mean you could change the position.
Kind of,
Kind of.
yeah. If there's an arrow that says this side up, you put that side up. Especially on these, because that voltage that's opening and closing that contact is very, very sensitive.
Okay.
So if you turn it sideways, it's not gonna open and close the way it's supposed to.
So it's not gonna make complete contact.
Yeah, it won't even open when it's supposed to. So if you turn it upside down, you're creating more, and it won't overcome the voltage.
Okay.
On this one, if it's turned sideways, you can see that the weight of that armature has to fall at a certain point. So if it's upside down, guess what?
It's not gonna fall.
Yeah,
It's
it's probably not
work
gonna fall at
properly.
all. Yeah, and then that causes the starting winding to stay in the circuit, and that start capacitor. The Feuerspulen.
Fire sprinklers.
Feuerspulen. Got that?
Positive temperature coefficient resistors. Compressors starting devices that are resistors that vary their resistance when their surrounding temperature changes. Having a low resistance over a wide temperature range. Used often in the HVAC/R industry in place of current and potential relays.
Okay, so we've all seen these and we've all handled them and touched them. We had one. That blue thing. Yeah, Spock's father. Remember Spock's father? Sirach?
Doesn't ring a bell right now.
No.
I'm pretty sure I did. But
That big blue thing about this big?
I think I
Had a little metal bracket on it? That said Sirach on it?
I wanna say yes, but I know
You saw it.
my brain's just.
You touched it. I know you touched it. His fingerprints are on there. Watch
I
out.
wanna see those fingerprints, Steve. I wanna see
Okay.
those fingerprints.
Evidence is there.
Okay.
Evidence is there. I want you to go
We'll
to
get
chronology.
to that as soon as we're done. We'll get to,
Okay, sorry.
we'll have
continue.
hands on. But we gotta get through this
Okay. Sorry.
today.
Two-speed compressor motors, used to control capacity of compressors. Speed changes made by wiring changes. The thermostat controls the wiring changes. Two compressors in one housing. One motor turned to 1800 RPM, the other at 3600. Two-speed compressors have more than 3 motor terminals.
More than 3.
More than 3.
Yeah,
That's
like
like
6.
4.
2 separate motors.
Oh, the two, oh.
That's more than one.
That's more
2
than-
compressors in one housing. Wow. Yeah, they were pretty popular, not so much anymore. You may see some out there,
What brought it down?
the cost.
Oh,
This
that's too
thing's
much.
expensive.
Mhm.
You got more than double the price on this thing. It's good for capacity control, so the unit can run at high speed under heavy load, and then once it reaches a load in the building, it just slows down to the other speed, and it just kind of maintains. So it uses less electricity, but the cost of those are really, they're
So
kind of
it's more like a
specialized.
Industrial type of thing?
No, it's actually residential.
Residential?
Yeah, there's a guy that lives right up here on Paul,
Oh, you did his
He
house
had
and
one.
stuff.
and I told him, I said, you know, there's a 5-ton split system, and I was looking at it, I said, this thing got a 2-speed compressor. I said, that thermostat talks to this compressor. I said, dude, if you ever need to change that compressor out, you'd be better off getting just a 5-ton unit and throwing it in there, because that's,
So
you know,
just getting it new.
just changing the whole unit. Well, yeah, you probably, if you're gonna lose a compressor and a condensing unit, it's,
It's cheaper to buy a whole.
yeah, it's better to buy the whole unit. But, in that case, in his case, it would probably be, you know, the new compressor would probably be about 3 times the amount a new unit would be, so. And he went to our church, or he's still going to the same church, but I was the one that left anyway. He said that, you know, too much information.
I love too much information about your personal life,
Yeah.
Steve. You know how to go
But-
into details.
We had just changed out, we had just taken two 5-ton units off the building, and they were single phase, and I said, I would get a hold of one of those and just store it here in case you have to change it, and then
When the time comes,
when the time
it'll be
comes, you know.
cheaper.
I told them, I said, time comes, we just move it over in place, take the other one out, boop. Bow,
Makes
bow,
Bow, bow.
bow, bow, bam, boom.
That makes sense,
And you
though.
got something that's.
It's nice to have spare parts, cause you never know.
Yeah. I'm pretty much out of spare parts, so in my unit,
We get to make our own
I
noise.
used them.
I guess so. If Steve is making his own noise, I guess
Do
we
we,
can.
do we get to come up with our own noises, or do we have to use those?
Yeah, and then my favorite one is fly.
It depends. It depends on the type of grade you want.
I'm just saying, I'll open that.
Special application motors, some single speed motors have 1 or 3 motor terminals, auxiliary compressor windings to increase the motor efficiency. Winding thermostats wired through the compressor shell. 3-phase motors have 1 thermostat for each winding, 5 in series.
Special motors. No, I'm not gonna add anything to that.
3-phase compressor motor, used in large commercial, industrial applications. Normally have 3 motor terminals, no capacitors are required. Same resistance across each winding, high starting torque. Some large 3-phase compressor motor operates as dual voltage device.
Wow.
That's
There it is. That is a 3-phase motor. It's
Wow, they're
actually
so
208
huge.
3-phase. And it's hooked to the compressor by way of a
Oh, yeah.
coupler. Coupler.
I
Right.
got that.
Okay, so this particular one is downtown. It was on Factory to You in the basement.
Factor two.
There's 3 of these down in the basement,
Wow.
3 of them, 1 for each floor.
Wow.
This is the
luxury.
filter bank. This whole room right here was a return air filter. Was a return air.
Wow.
For the entire building. Wow.
That's luxury
Yeah.
to its max right there.
Uh-huh. The handprint right there, can you see it?
Oh!
That's mine.
I really noticed that. Wow.
I leaned over there and I looked at that, I looked at that coupling while the thing was running, I'm going,
I
there
bet
should be
it
a
was
cover
dirty.
over there.
Oh, then it was super dirty down there, no?
Yeah.
All that dirt and stuff.
The filters are clean now.
Next to the.
Okay, so this is over at Southwest Traders. This is the same type but bigger compressors. The motors, see the motors back there?
Uh-huh.
These two compressors control one freezer.
Wow.
One freezer.
How much freezers did they have?
They had about 5 or 6.
Wow.
So this is basically just cold storage for product, food.
Food.
It's just a warehouse where they drop stuff off and then they
For
distribute it.
produce.
Yeah, well, they have medium temps, but these were freezers on this one. So the medium temps were for fresh food, these happen to be for frozen stuff. You'll see those trucks, I've seen these trucks, Southwest Traders trucks, and what they're doing is they're taking product and they're delivering it to local restaurants and stuff. So, like I said, these two are for one box. And when you say it's a walk-in, it's a big box, it's not a walk-in, it's a drive-in. Cause they use forklifts going in and out.
That would make sense, cause, I mean,
Yeah.
heavy boxes.
Yeah, this was one of my accounts that I took care of. That's it. I don't wanna tell you my personal life, though, I won't say anything, I want no more stories.
You're cutting us off.
Okay, variable speed motor. Motor speed decrease during low load conditions. Voltage, frequency determine motor speed. New motors controlled by electronic circuits. Variable speed DC motors, ECM DC motors can ramp up or down to reduce motor wear. AC current can be converted to DC using I don't know.
Rectifiers.
Rectifier.
We're gonna rectify the situation real quick right now.
Oh.
DC converts rectifiers, phase controlled rectifier converts AC power to DC power, uses silicon controlled rectifiers and
Transistors?
yeah. Capacitors smooth out the DC voltage.
Okay, so we talked about the AC turning DC with the bridge rectifier.
Mm-hmm.
So here's what you got coming in, then you end up with this. Pulsating positive DC. So anything below that line is gonna be negative, this is gonna be positive, so it's all negative and positive now.
Cut that negativity out.
Huh?
You said cut the negativity out.
But then it becomes, it's actually neutral, but it comes negative. When there's nothing below it.
Mm.
So when it talks about the capacitor is gonna flatten out the pulses, that's what a capacitor is gonna do. It's gonna store a little bit of electricity and it's gonna smooth out these humps. So that's what a basic power supply looks like. It looks like that, but it's smoother. Okay? Okay, the bridge rectifier does not regulate the DC voltage. You'll have to have a regulator in there. And what the regulator is, it's another diode. It's called a Zener diode. Now the Zener diode it not only allows current to go one direction, it only limits it to a certain point. So it won't allow too much to go past. So it's like a check valve with a regulator on it. Voltage and frequency are then adjusted. So on these right here, if we go back to this right here, if you're gonna do residential work, you're gonna see a lot of these ECM motors, because all the new units have ECM motors in them. They do that because Title 24 required it. Title 24 is the energy commission that says we have to make air conditioners so much more efficient. So in order to get the higher efficiency, they're using the ECM motors, which is a variable speed. ECM stands for electrically commutated motor.
Okay.
And we'll talk more about that later on. But these are gonna be, you're gonna be working on a lot of these.
Those are the most common ones coming out now.
All the new ones, all the new equipment is all gonna have
Okay.
these on now. So when these things go bad, you're gonna have to troubleshoot. And what's happened in the past is technicians were going out, they don't know how to troubleshoot them, they're saying this thing's bad, and they're replacing it. And it's under warranty, so they send it back to the factory. So the factory checks all of them when they get them back, and they're finding out there's nothing wrong with them. They just,
People hate them.
yeah, they're not diagnosing it correctly.
Um,
So the manufacturers now send people all over the country to give seminars on how to troubleshoot them, how to check them, how to do all that stuff. So
how to do it properly.
my advice would be, anytime there's an ECM motor seminar, I'd go to it. No matter what their manufacturer, because every manufacturer is gonna have a little bit different design and a little bit different way of troubleshooting.
Mm.
And they're probably gonna sell you their test meter. And each one has where you can plug it in and it tells you what's going on with it. So it's a meter that plugs right into the motor, and they're gonna wanna sell you theirs.
So it'd be like a car, like you just put it in,
Yeah.
It checks the sensors.
Yeah, that's exactly what it does. Just like when you plug into the computer in your car. So those tools are gonna be, you're gonna need those to, you know. They do make a universal test module, but I don't know how well it works.
Obviously, because every manufacturer is
Gonna have their
different.
own, and
Yes.
you know, you don't wanna carry 5 test modules, cause the test modules are gonna be like a couple $100 a piece.
I wouldn't doubt it.
So, that's one of the questions you might ask if you go to these seminars, is you got a universal test module, can you use it on your motor? So the motor might be a General Electric, it might be an Emerson, it might be a Marathon, but all these manufacturers are now moving to ECM motors, because that's what the law requires now,
Obviously, well,
okay?
yeah.
So that's continuing your education, that's what it's gonna be. Got that? Okay. We got that, okay, so. What did I say?
Inverters and variable frequency drives. Varied frequencies obtain desired speed. 6-step inverter receives voltage from the converter, can control the voltage or the current. Pulse width modulator receives fixed DC voltage from converter. Short pulses at low speed, long pulses at high speed.
Okay, so VFDs are the commercial answer to the variable speed motor. Just like ECM was the answer to the residential line. VFDs operate in higher horsepower motors. So the VFD, variable frequency drives, are a little bit different in one way is it takes the alternating current, and it's usually 3-phase. They'll take that current and they'll convert it into DC. That's the first step. And then once they convert it into DC, they invert it into AC, 3-phase AC. And what they do with that 3-phase AC, now they can, once they've created their own AC current, now they can vary the frequency. So it's no longer 60 cycles coming in, they can't do anything with that. So they make it into DC and then they reconvert it into AC, and they vary that frequency. That's what causes the speed, is the variable frequency. So they're varying the frequency that's going into that motor that varies that speed. And what's interesting with these VFDs is the frequency, the output of the VFD drive can be any frequency you want, whatever you program into it. So, I'll tell you a story. Want a story?
Yes.
Okay.
Let's go. Either way, you said no
I
more
was
stories,
over
so
at-
let's go.
I was over at Coles over there on Alluvial, and one of the technicians was over there, and he goes, I one unit he was having a problem with, so I went down there and I checked it out, and I said, "This unit here?" And he goes, "Yeah." And so I fired it up, and that thing sounded like there was a plane going overhead. And I go, "What the heck?" So I shut it down real quick, and turned off the fan, and I got to looking inside the program of the VFD, because they all have to be programmed a certain way. It's just like a thermostat that has certain codes for certain things. So you have to have the book in order to find out what codes mean what in this thing. So I was looking at it, and he had set the frequency up to like 90. So it was running at 90 cycles. And I saw that, and I said, I called over to him. I said, "Hey, did you push buttons on here?" He goes, "Yeah, I didn't know what I was doing, but I was pushing the buttons." I go, "Yeah, that makes sense, because you get the frequency at 90. That's why it sounded like it was, I mean, it was spinning, man. And we don't want to do that because it's hooked to a blower wheel with a belt, and the blower wheels are rated for a certain RPM.
Oh, so
So
can
you
blow
exceed
down.
that RPM, that blower wheels start to come apart. Then you got a big problem, even
Bigger
bigger problem. So, want to keep it down below 60, and that's what they did at Kohl's. The Kohl's issued they issued a standard of all of the frequency drives needed to be programmed for high speed was 55 cycles. First stage or second stage cooling was, well, like I said, 55 cycles. First stage cooling was, I don't know, I can't remember. I think it was 45 cycles.
Okay.
And then heating, when it went into heating, there was a certain cycle for 2 stages of heating. So it was like trying to remember now. It was like 25 cycles and 35 cycles for
Between them.
first and second stage heating. And then when the unit was off, the temperature was satisfied, that blower would run at about 15 cycles all the time. So that's how they wanted it programmed. And what they did is they took a thumb drive, and so every time we went out to Kohl's to program one of those VFDs, we could plug that thumb drive in, and it set the program in the VFDs. But I didn't have the thumb drive, so I had to kind of guess. I looked at another unit that was programmed, and I went through all the parameters, and I just set the other unit up the way the other one was. So, and I had to do it manually, but because we had a lot of problems with these VFDs burning up. I actually went on one. It was in Vallejo, California. I think it was in Vallejo or Visalia. Or one of those V cities. And the VFD was, and there was a whole process you had to go through. If you found one that was bad, you had to call this one number, you had to get a PO, and then you had to call Emerson, the maker of the VFDs, and then they had to issue another number, and then you had to call Kohl's or Evergreen Air Conditioning, and then they would issue a PO to get the unit, and they would call, and their PO would have to go back to Emerson so they could replace the VFD. It all didn't happen in one day. It happened in
Like a week.
a couple of weeks, yeah. It's because they had to ship it out from wherever. So
Wow.
generally, when I found them, I mean, it was pretty obvious that the wires that came in to the VFD coming out, the 3-phase,
Okay.
the ones that coming out are all burnt. As soon as I opened it up, I was like, oh, we got a problem with the VFD.
And then you started calling them.
And I made all the phone calls and everything. And
So
what
you
I-
gotta make like 3 phone calls before
Yeah,
you get a hold of them.
because there's so many people involved. So what I did is I just wired the power direct to the motor, so it jerked the whole roof when it started. But that's all we could do. You know, you wanted to get them going, so, because nothing's gonna work on that unit if that blower stops.
Makes sense.
It's not gonna, you're not gonna do anything, so,
So it's like a temporary fix.
yeah. And we had to do that, found out later that we did that a lot, because we took care of 60 cold stores, all up from Visalia all the way up to, Eureka. Huh?
Nothing.
Eureka.
Eureka.
Eureka. Huh?
Steve's like, yeah, I like to drive.
Yeah, that's right, yeah. I did a lot of driving when I wasn't in the office. Okay, so these are VFDs, you're gonna see a lot of them because, again, Title 24 requires anything above 5 ton or anything above 5 or 10 ton have to have VFD drives on the blowers. And some of the commercial units even have VFDs on the condenser fan motors too. I installed some over in Victorville that fans were going real slow. I'm like, what the heck? It was on VFD. I mean, it was not a VFD, but it was an ECM motor on that because they were smaller units. So that's what one of them looks like. They all look different. So you have all the controls for programming. You have to read out the screen that tells you all the codes and your parameters. So 20 years ago, this VFD, it's about this big.
Okay. Not that big.
20 years, I'd say 30 years ago, this VFD was a big mainframe.
Wow. Like
So, the
a server? Do a big server?
Yeah.
Definitely.
that big, yeah, because I walked into a equipment room, electrical room, and the whole wall was lined with VFDs. And the guy said, these are all our VFDs. I'm like, okay. Then they started coming out with smaller ones. But you have to have the information on this, you have to have the instruction manual in order to program it. You can't do it without that. So, here's the ECM motor. What does it say? I can't read.
Electronically commutated motors. Used to open drive fans with less than 1 horsepower. Armature commutated with permanent magnets. Motors are factory calibrated. 2-piece motors section and controls. Motor can be checked with an ohm meter. Controls can be checked with a test module. Defective controls can be replaced.
Test module, right there.
Cooling electric motors. All motors must be cooled. Pneumatic compression motor are cooled by air and refrigerant. Open motors are cooled by air. Open motors must be located where there is a good supply of air. Some very large motors are cooled by water.
Okay, any questions with that? Cooling is pretty important on your motor.
Obviously, you don't want the motor to heat.
Yeah. Oh, look, we might get this, we might finish this before break.
That was some story.
Who's gonna summarize?
So the
I did it last time. I'll do the last page.
Summary. Motors facilitate the circulation of air, water, refrigerant, and other fluids. Some applications require high starting torque. Motors components include the housing, the rotor, the stator, end belts, bearings, and motor mount. Summary continued. Electricity and magnetism create motor rotation. Motor speed is determined by the number of poles. The start winding has higher resistance than the run winding. Important motor amperage are LRA, FLA, and RLA. Resistances are supplied with single-phase power. Some motors are designed to operate at more than 1 voltage. Split-phase motors have medium amounts of starting torque and good running efficiency.
summary continued. The centrifugal switch opens and closes its contacts depending on the speed of the motor. The current relay opens and closes its contacts depending on the current flow through the run winding. Summary continued again. The potential relay opens and closes its contacts depending on the induced voltage across the start winding. Capacitor start motors use start capacitors to increase the starting torque of the motor.
Summary continue. The start winding and start competitor, I cannot speak.
Capacitor.
Capacitor are removed from the circuit after the motor start. Capacitor start, capacitor run motor. Use both start and run capacitor. Run capacitor helps increase the motor running efficiency. Summary continue. The PSC motor use only a run capacitor. The shade pole motor has very low starting torque. Three-phase motors are used for commercial and industrial applications. Summary continue. The PTC and NTC are electronic devices that charge their resistance as a sense temperature change. Variable speed motors ramp up and down, often use DC converters and
Inverters.
inverters and rectifiers. ECM motors are commutated with permanent magnets.
Okay, you wanted to read the last page, so. All the big words, huh? Okay.